Thank you, Idan. Thank you, Aviv, for inviting us. And thank you for the opportunity to speak with this amazing panel. And what I wanted to talk to you today about is something that I call a tool that I would like to share with you that I call cycle diagrams. And this is something that let me know if you can see my slides. Are we good? Okay. So I called it the giant steps progression and cycle diagram. So just to give a little bit of background, I was at a workshop with Gary Bartz, and he said something like this, that basically all jazz harmonic progressions and substitutions can be deduced from studying cycles. So I kind of took that challenge and tried to figure out like what exactly he meant. And as a result of that, just to clarify things to myself, I wrote this article that is linked here, and I put a link to these slides on the chat. So if you want to copy it out and follow along, or if you want to look at it later. And this article got quoted or referenced in the Coltrane changes and interval cycle Wikipedia entries, which kind of brought it a bit of attention. So everybody knows about cycle of fifths, cycle of fourths, 2-5-1 progressions, those types of things. And I was kind of asking, well, is there a more systematic way to investigate these cycles? And are Coltrane changes or giant steps progressions and those types of things part of those harmonic cycles? So let's start by just looking in general. We know that music is made of cycles at all levels. Individual tones are cycles. Sine waves, strings that are plucked are waves. About the overtone series, about harmony having to do with it. And of course, today we all know about cycles and waves in loops and recording. And if we listen to any pop song, we usually will, as musicians, we know that there's probably like a 4-bar loop of drums there that keeps repeating. And then the same thing on form. Musical form is kind of a bigger type of cycle that is also a part of this type of things. And cycles are really everywhere in our life, and they can we can see them in other forms, not just in music. So I wanted to just show you one quick thing, which is that if you think about a circle, which we sometimes look at as a circle in terms of a cycle of chords or a cycle of fifths or something like that, you can see that it's actually the same as what we call a waveform. So there's no real difference between them. Just one is shown over time, and one is kind of a static view, just to give you the idea. But the nice thing about the circle view is that it gives you some geometric type ideas that you can see. And the analogy is obviously to a clock. We have since the 16th century, thanks to some Chinese scientists, we have the equal tempered scales or tuning, and that gives the 12 notes, which are exactly an octave. And so a cycle of the chromatic notes is exactly like a clock. And if I tell you it's 10 o'clock and I'm going to meet you in 3 hours, you know how to do the math. It's 10 plus 3 is really 13, but you know that you have to subtract 12. And so that's a modulo operation. And the same type of thing works in music as well. And you all know how to transpose and how to do all those things intuitively. But there's a mathematical, beautiful kind of idea behind this, which is that we think in these things that we sometimes call groups. And I'll talk about that next. So the idea of groups is really what brings the cycles into kind of a bigger context. As Aviv mentioned in the beginning, there's you can see these parallels between math and music and art, and this you can see this in these cycles that, for example, if you take a triangle, you can rotate it again, you're going to get back to the same thing. So that type of thing is part of group theory. In this short amount of time, I don't have time to go into it. but I really, if you find this stuff kind of fascinating, I think the Mario Livio book on the bottom left is a great place to investigate this. He goes through all of these ideas and brings examples from art, from music, from physics, how all of these things are really examples of the same idea of cycles and operations on different states that bring you back to the same spot that you started. So what does any of this have to do with Coltrane? Well, maybe the Slonimsky book. I think a lot of people know that there's some evidence that he was very interested in it in 57 to 59, and of course 59 is giant steps. So there's a good chance that he looked through this. And if you just look at the table of contents, what you see is that what he does is he takes octaves and he breaks them into equal parts. And then from that, he brings cycles. So one octave into 3 parts, into 4 parts, into 6 parts, and that kind of thing. And then he does all sorts of elaborations. And then, of course, the ditone progression, he calls it the ditone progression, is a division of an octave into 3 equal parts and is intervallically equivalent to an augmented cycle. So we'll see how that, we can see that as a cycle in a second. To move on, I'll start by looking at this thing which you all know, and just show you some things that maybe you can see geometrically that you're not used to seeing when you look at it in sort of on a piano or on a guitar string. So, for example, when you look at the so this is the chromatic cycle in both directions, and this is cycle of fourths and cycle of fifths, but check out some things that are not so obvious. For example, every note is opposite its tritone. Okay, well, if you think about it, that is obvious because we just said that divides the octave in half. So obviously, if you go halfway across the circle, you're dividing the octave in half, and that's so north south are opposites, and that's where the tritone comes in. But also notice that happens on the cycle of fourths and fifths. That's pretty crazy if you think about it, right? Each note, 6 semitones, is also equals to 6 fourths or 6 fifths. So now suddenly you're seeing something that you can't really see in other ways, and you're getting a new insight from just the geometrical way of putting these things together. Now also look at north, west, east, and south, which I have with arrows here. And those are the same too. And wait a minute, why would that happen, right? Again, it's not very easy to see in other ways, but here it becomes very clear that a minor third is the equivalent of 3 fourths going up. And maybe that explains why McCoy thought of this, C, F, B flat, E flat as a way of harmonizing a minor third. And then of course, continuing with the logic that Gary Bartz mentioned, you could say, here we're going 5-1, 2-5-1, 6-5-1, 3-6-5-1, all of those types of harmonic progressions can come out of this. And then you can also link these two cycles. Right now, think about this. We're going from C to F. Now flip F with its tritone with a halfway across. So now you're C, B, B flat. And so now you're basically turning a cycle of fourths into a chromatic cycles. So there's a lot. So that basically shows you that the tritone substitution and all that type of stuff. So the next stop along this is the minor third or diminished cycle, and this you can see this by creating a little square inside of that circle that we created before. And again, the north, east, west, south can extract them. And then when you turn that, which is again this kind of like symmetrical operation, you turn it to D flat, you get the next one. You turn it to D, you get the next one. So again, you're seeing some beautiful symmetry here, and 3 squares fit into this circle, which again you could think of 3 times 4 is 12. And the other nice thing here is, again, we've maintained that each note is still opposite its tritone. So you still have this relationship between the notes. And of course, there's not a lot of great progressions that go along with the minor third cycle. The next one, and the one that brings us basically to the interesting ones, is the whole tone cycle. And the whole tone cycle is created by creating a hexagon within the circle. The hexagon has 6 sides, and you go C to D to E and so on. And how many of those are there? Well, of course, there's only 2. You can turn the hexagon 1 over to like D flat, and then you can, once you turn it to D, then again, you're back in the same one. So the symmetry comes out of this. And then again, opposite each of the tones here, you're going to find a tritone. Again, it's not a big mystery. It's 3 whole steps, but it's nice to see the symmetry visually within this. And finally, when we get to if we look at this hexagon as 2 triangles that are flipped, then you can see that or you could look at it as a Magen David. Then you can see the giant step cycle. So the giant step cycle, there are 4 of them, and they're the 4 triangles inside of these hexagons, and you can see that that the one on the top right is the giant steps one, and then the one under it is Countdown and Miss Jones bridge. Since I'm kind of running out of time, I'll go quicker onto this. So you can see that the way Coltrane handled this was he basically did something like 2 steps in one direction. So G, E flat, and then 1 step back. So the first part is like 2 steps forward, 1 step back, and then the other side goes, the B part goes the other way. So again, you can see some symmetries and some logic here that are easy to see with cycles that are not so easy to see in other ways. And then the countdown progression is very similar, except it's the one that starts in D. It's one of the other triangles. And again, he takes the 2, 5, 1 and if you just replace it with a giant steps progression with starting on D, you would get this line with the blue, and then if you just replace that by its second degree, then you get the countdown progression. And we could do the exact same idea of showing how this goes by colors. You're going from D to G flat to B flat, then it goes down a whole step, so you can now see it in C, and now you're going to the other one. And then it goes back, because once you get to B flat, you're basically back to the same triangle. So these are basically some of the things that you can see with cycles. So just to close it out, cycle diagrams are related to the mathematics of groups. If you're interested in rotations, reflections, group theory basically shows you how to deal with symmetry in all forms of music, physics, math, art, and so on. And we can see the beauty of the musical cycles through thinking about them as a circle. In each circle, we can see 2 hexagons. In each of the circle, we can see 3 squares or 6 triangles, and each of those represent the progressions and give you a little bit of insight. So in the original article, I have some more ideas about how you could use these cycle diagrams. But again, the idea is visual equals auditory. And if you use some of these ideas, you can maybe come up with some new concepts. So thank you very much.